Okay, so let's take a look at your predicting redox reaction questions. So 1A says, during a chemistry education demonstration, zinc metal, so set in, wow, is it ever blurry? Let's see if we can make that better. There we go. Set in solid is placed in a hydrochloric acid solution. So H positive aqueous, Cl negative aqueous, H2O liquid. Okay, so you go to your table. That seems to have disappeared on me. Oh, there it is. And you find your zinc metal. It's down here somewhere. There it is on the reactant side. So it's going to be an Ra. On the reducing side, excuse me. We had found our H positive in the example question. It's our OA, an OA. We found Cl, if you remember, twice on the table. A Cl here linked with the water, and a Cl right below it by itself. So Ra and Ra. And then water, of course, shows up as both an Ra and an OA. So we have all our entities. Now we have to figure out which one's the strongest oxidizing agent. Which one is closest to the top? So we only had two. We had our H positive. You think I could remember? How come it's always the H positive that I can't find? It's always lower down than I'm expecting. There it is. And the other one was our water, which is way down here. Okay, so the H positive is definitely our strongest oxidizing. For reducing, we have our set in down here. We have our Cl linked with our water, our Cl linked with our water, and our Cl alone all up there. So it is our Z-in, that's our positive reducing agent, our strongest reducing agent. So strongest reducing agent, strongest oxidizing agent. So now we write our half reactions. So for our oxidizing agent, it's going to be 2H positive, positive's in the wrong spot, aqueous, plus 2 electrons going to H2 gas. And for set in solid, remember you read backwards across the table when you're writing this down, set in 2 positive aqueous plus 2 electrons. Electrons are balanced between the half reactions, so we can go ahead and add them together. 2H positive aqueous plus set in solid going to 2H2 gas plus set in 2 positive aqueous. So there's our half reaction. We now go and look at the chart. Find them again. Zinc is down here. Just for the record, it's a lot harder to find them when I'm looking through the iPad. And H positive is there. My oxidizing is above my reducing. This is spontaneous. Okay? 1B says, in industrial production of iodine, chlorine gas, so Cl2 gas, chlorine gas is bubbled into seawater containing iodide ions. So there's iodine ions, and it's seawater, which means there's water, and seawater is salt water, so NaCl. Okay? Cl2, when you look on the chart, it's up here at the top. Okay, so it is an oxidizing agent, OA. I negative, when you look at the chart, is right here. It's a reducing agent. Water, hopefully by now you remember, it's both an OA and an RA. Na positive is all the way down here at the bottom on the oxidizing agent side. And when you're doing this, you should double check to make sure it isn't anywhere else. I know it isn't because I'm old. And Cl, we just did up here. Cl is a reducing agent by itself. And it's, it should be an R. And it's a reducing agent linked with water. Which one of these two is closest to the top? Well, the Na was like right down at the bottom. So I'm pretty sure it's going to be... I'm missing this one. It's going to be the Cl2. It's really close to the top. I was thinking the danger of having your camera like that. Okay, and which one is going to be closest to the bottom? It's going to be your iodine. Okay, and so now we write our half reactions down. Cl2 gas plus 2 electrons going to 2Cl negative aqueous is our oxidizing half reaction. Our reducing half reaction will be 2I negative aqueous going to I2, which is a solid, plus 2 electrons. They are already balanced, so you can just add them up. Cl2 gas plus the iodine ions going to 2Cl negative plus the iodine that you wanted to create. Okay? Then you check to see is it spontaneous or not. Cl is up here. I negative is down here. OA is above the RA. It is spontaneous. That is good news since you are trying to produce the I2. It's good that this is spontaneous. 1C says a gold ring, Au solid, is placed in hydrochloric acid solution. H positive aqueous, Cl negative aqueous, H2O. Okay, so hopefully these are getting a little easier. Au solid, when you look for it, you will find it all the way up here on the top on the reducing agent side. It is an Ra. H positive we've done several times. It's an OA. There's when we did it up here, it was with the Cl and it wasn't linked with it, so I don't have to go and look. But we know our Cl is an Ra, and we know it's an Ra linked with water. We know water by itself is an Ra and an OA. Okay, so we have all our different things. Now we need to go to find which one is the strongest oxidizing agent. It's identical to what we did up here when there were only two, and it was the H positive. So this is the SOA. Now we need to find which one is the strongest reducing agent between the Cl linked with water, the Cl by itself, and the water by itself. It's the water. That's the strongest reducing agent. Yes. So our strongest oxidizing agent will be 2H positive aqueous plus 2 electrons going to H2 gas. And our water one is 2 water liquid going to O2 gas plus 4H positive, that's aqueous, plus 4 electrons. So I need to multiply this guy by 2 to balance the electrons. And now I can add them together. So we have, since I wrote the 2 down first, we'll put the water here first. 2H2O liquid plus 4H positive aqueous going to 2 hydrogen gas plus O2 gas plus 4H positive aqueous. Okay, so now look, 4H positive aqueous and 4H positive aqueous, you can cancel those out. So what you're left with is H2O liquid going to 2 hydrogen gas plus oxygen. And then you have to check to see if it's spontaneous. So here's the H positive and here's the water. The Ra is above the OA. It is non-spontaneous.